Hi guys, you're welcome to God Academy. And in this lesson, you're going to solve a couple of problems in calculus with several variables as you prepare for exam. So this is God Academy, and if this is the first time you're joining this channel, please do well to subscribe. As a student, you're going to need so much help along the way. So in this lesson, you'll be solving random problems because you want to simulate the real exams condition. In exams, we don't have section for integration separately from section for differentiation. We just have random questions. You should be able to answer the question. At this point, so if you have prepared in quotes for your exams, ideally you should be able to solve any question that's confronted with. When I share any question, you can do something to help yourself by simply pushing down and solving separately. Pause the video. But if you ask somewhere, follow close, solve that way. So let's solve the first problem. Here we are going partial derivatives problem. Subtopic in calculus with several variables up with. So I have a problem here. Equal to cosine of x squared plus 2 minus e to the power 4x minus e to the power 4y plus y cubed. So this is the problem at hand, and this is a function we have, and we are supposed to find the partial derivatives for this function. Problem here. So find all the partial derivatives. Yeah, so when you come to partial derivative, one thing that confuses students a lot is that I have x, I have y, I have z, and all that. How do I differentiate independent of each other? So anytime you've been asked to find the partial derivatives, so for this one, you're going to find wx, wy, because we've got three separate variables. If you are handling wx, you've got to close your eyes, assume that anything not x a constant or is simply a number, as you know. If you are doing w sub y, then anything which is not y here, number, which you don't think about. So far as this partial derivative, we are different. And finally, we have w sub z. W sub z also going to as z as function. Another thing. Having that in mind, w is equal to cosine of expression x squared plus 2 e to the power 4x minus y cubed. So if you're a student and you see this and you get scared that this is scary, I can't do it, right? Anytime you see a mathematical problem, don't frighten. Don't just get scared or don't add the complexity at glance, okay? Just write it down for composure. Assume that you can do it. Then start by asking yourself questions. So let me write it back again. So w is equal to cosine of the expression x squared plus 2y minus e to the power 4x minus the power 4y plus y cubed. Having this, you want to find w sub x, or our partial derivative with respect to x. The first question to ask yourself is, where can I locate x within my function? So I can look x in this part. For one, I can locate x here. Any other term within a function becomes a constant, which you should never look at. That is the first thing. So you realize that this is y to the power 3. You don't need it. It's not x. So with this particular partial derivative, don't consider, right? So that is the first step. Identify where you can find x, and any other terms will be set to 0 or is not. So now, once you identify the terms of x, you are still not done. Within that, there are other um, variables, right? So this x squared plus 2y. Because of this x squared within the argument of cosine function, you wouldn't just say that 2y is going to 0, right? You're going to simplify the expression accordingly. But in your mind, you know that this y here is not y. It's just the value of a constant. Okay, so let's start. This is a composite function. I have a quadratic function within the argument of a cosine, a trigonometry. So we use substitution to solve this. And at this point, I believe that you wouldn't go through traditional substitution approach. Let's you cause this and that. Yes. But you can use your eyes, you can just enter tricks here, then you get your answer, right? But for the purpose of this tutorial, I'm gonna take you through step by step so that you get everything. So let's do be equal to x squared plus 2y. This is to help us simplify expression. Okay. Anytime you want to make variable a different term or to change your subject of differentiation. We are differentiating with respect to x and we want to change everything. Therefore, p different. So let's see. So I'll have, so I'm just taking this side. Okay, just isolate out of the whole function. So please get lost. So here I'll have, so for here I'll have my dx equal to I have to, right? Therefore, I have x, then make the x the subject, or yes. So I don't want to confuse you. Here we use chain rule to simplify. So this is the udx, right? Then we have to set this certain variable. So let me see. Now we have cosine. Please just take note. We are just doing this. We are just isolating. I've made u at the argument. That is x squared plus 2y. So I have cos u here down. So let's say this isolated section of our function can be called, right? So let's say p sine of x squared plus 2y. Then that means that I'm going to have equal to cosine u, and not it. Therefore, the derivative of this entire thing is going to be a chain. I'll have over du times du over dx, right? So when I differentiate the p, what am I getting? If you differentiate cosine u, negative sine, and you multiply that by what? Negative sine u times your du dx is also. Therefore, the entire derivative of this expression is negative 2x sine u. Then you play back again. So I'll simply have here to be negative x sine, and u is what? X squared plus 2. So that is how we do it. So without going through this, you should have used your eyes to say that is going to be substitution. I'll simply find the derivative of this. I'm going to get 2x will multiply the entire thing. And after you do that thing, of the negative sign of, that is all. You're not done. we have another part of the function that is e to the power 4x minus 4 multiplying y. So once we have this x, how do I cheat the expression x here? X is not standing, it is within an expression 4x minus the power 4 multiplying y. So this is an exponential function. How do we do it? A function. For any exponential function, simply use the same substitution, right? So here you have e to the power 4x minus power 4y. Now I have to make my power subject 4x minus power 4y. I want to find the derivative of this function with x with respect to x. With respect to x, I'm going to get 4. So du x 4. So now I know that du dx x into now set this whole thing. So what will then p be equal to e to the power u. Now remember the p is going to be the same thing. When you different exponential function as a unit, get the same back again or u, right? So now our answer is e to the power u times so dp dx equal to dp times d, that is e to the power u times 4. So I'll simply come here and I'll have minus 4 e to the power, my u is 4x minus e to the power 4. Remember this will be 0. Our answer, partial derivative with respect to x. Don't, whenever you see how appears, just take your time, ask yourself, where is x? If you are not a term containing x, obviously, next term, how do I get this x out of its position to be cheated? Then you go through the step as we did. The next thing we're going to y. Back to y, that is wy. What do we do? It's where we can find y10. That is this one, but they all have got y. So when I come here, similarly at this point, I don't think the same process follow me up and say that when I differentiate y, this is a constant, it will be 0. I'll get therefore my answer will be negative. Multiplying cosine, sorry, multiplying sine negative to x squared plus 2. That is for the should bear me out. Then minus, when I come to this end, now I'm different to y. Remember that I made u for x power 4 when I differentiate with respect to y this time around. This will be 0 because the 4x doesn't have a y. So then I have negatives the power 4y. If I am different this with respect to y, then it means that negative z to the power 4 is a constant. Since y is just to the power 1, I'll end up getting negative as a result of y is simple. Understand this. Once you get this, then you realize that we have negative minus z, right? You are doing this, you are doing this, or you can negative z to the power 4, then it will multiply whatever I I sub w sub y is negative sine of x squared plus 2y So this becomes plus c power 4, 4x minus power 4y. And finally, we can do sub z, and w sub z is plus. So w sub z, now this term doesn't go away. This focus on it this risk. So I have my have negative 4x minus power 4. I want to this is a constant. This alone, but negative 4, right? Add negative 4z. Somebody will ask, why did you are considering z? Then it means any other thing is if I had to, let's say if I had d to the power 4 times negative 4 times mostly partial derivative know y to be y, not assuming that it's a y trick. That makes it try your best possible to have that as time you're doing these types of them. So once you have now next thing, write our answer sub z. I'll have negative times negative positive 4z y e to the power 4x y. That is all I have for you. Let's quickly move to our second problem. I want us to do something Lagrange. Lagrange. Find maximum, probably minimum value of a function f of x, y, given as squared subject x squared plus y squared. Find the minimum of x, y, z, given as y squared, subject to constraint x squared plus y squared equal to 10. So how do we, is a typical optimization problem of the object well as with the constraint. So our objective function given as f of x, y, z, that is y squared, given as half x squared plus y squared. Lagrange multipliers is a constant that helps us to variable side. The single variable, simplify your derivative, put it to zero. That's which, but you realize that in multiple variable, you would end up getting fewer equal method. So the Lagrange multiplier that's that limit. So what are the sub equations? The Lagrange multiplier says that find your fx should be equal to gx times your lambda, where lambda is a Lagrange multiplier. You find fy is equal to gy times your lambda, fz equal to g sub z, and final equal always your constant. That's all. So the last equation, g of x is equal to k, which is our constant. So let's write this equation. What is f sub x or f of x? In my function, there is no zero. Say that it should be equal to g sub x. What is g sub x? When I differentiate, I'll write my x times. The next one is f sub y or fy. So fy is what? When I come here, my y is what? Y squared. So it becomes 2y equal to when I come here, gx is the same as 2 and lambda. Then fz here gives me negative and is equal to here is um fz is negative 10, right? When I come here, lambda. So this is equal to 1, equation 2. Then your last equation has to come to x squared plus y squared plus squared equal to 36. That is it. So now we have all our 4 equations. What's next? Next is to find the values of our optimizing it. Lambda as midpoint out of the. You realize that ultimately have different. So here we are at the critical point, we get peaks, either the maximum or the minimum values. So any value we get here is going to give us an optimized value, either the max or the minimum. So here what we do is from equation 1, you know that s is because for this to be 0, get x to be 0, right? But it's still not confirmed. Let's see something. You really have to get the values of before you can. S could be. Let me hold on with finished before we come there. So now is basic calculation. Let's check equation 2. I have then this. I have 2y minus equal to 0. 2y open bracket. Realize that 2y is equal to 5 will be 1 minus lambda equal. So now we know lambda is 1, y is 0. Lambda is 1, that x is going to be 0 for this. So therefore we know our goal. Lambda is equal, x is equal to 0, y is equal to. Then let's find z. Now what was z? So when you come to this equation, or we can find, sorry, you can find a z from constraint. So you have 0 squared plus y squared, and y is also 0. So another 0 squared plus z squared is equal to 36. Therefore, my z from the constraint will give me what? Plus or minus. Therefore, I'll have two separate points from this side of our calculation. I'll have 0, 0, negative 6 as a point, 0, 0, positive 6. Two separate points which are at our extrema. So these we cannot tell whether they are maximum or that they are extremes. Sure. So that is what you've got x from the calculation, y from calculation for the corresponding z of our constraint. The next thing to do is there is still a chance of getting another set of values. Somebody will ask why. Because we are not done with our third equation to see exact value of. If z happens to be 6 here, then fine, we are done. If we get a different answer, we are not done. Then you know that negative 10 is equal to 2x. Sorry, 2 lambda. Lambda is 1, so know that 2z is equal to negative. Therefore, z is simply going to be what? Negative 5. If z is negative 5, then you are getting something new. All right. So z is negative 5 and x 0, right? So what are we getting? Are we getting? Okay, so I have z. So within our constraint, know that x is 0, right? I'll have y squared is, so y is 0. So let me find the values of y here. Since I know that z is 5, y squared plus 25, y squared is going to be 7, y is equal to 7. Now, what I'm showing you here is you want to get the point, analyze the extremes, which will be maximum of this. Got us direct answer because we had x and y. And now from here, we have gotten z. So we have to get the corresponding value from our point. That's why you are finding this x equals 0. So once you have this, that's the next point is have x to be 0, y to be positive 4. I can have 0, negative, have positive. So we have four separate points. Point number 1, number 2, number 2, number 3, number 4. Somebody may ask, how do I know which is maximum and which is minimum? So to know which one is maximum and which one is minimum, then what you are going to add, you are going to have a function, objective function back again. My function f of x, y, z equal to y squared minus. Now you test a function of 0, 0, negative. What do we get? Y is 0. So negative 6 gives us what? Times this. I have 60. I'll test for the positive 6 and that will give me 0, 0, 6. That will also give me negative 60. You can see that. Then I have to test for negative root 11. 0, then negative 5. So if y is 11, that will be what? 11, right? So let me do it. Yeah. So if y is y squared, then I'll have 11 minus, this becomes 10 times negative 5. That will be positive plus 1, right? So meaning that that is more than this. So without even going further, I know the maximum. When y is positive, so whether y is positive or negative, I think the same answer, or we are not getting, because it was positive. So therefore, our extrema will be this point. So these 2 points are all extreme, by giving us the maximum value. So check, find the maximum and minimum value. That's what you are looking for. And what is it? That 61. 1 is maximum. So this is observation using Lagrange multipliers, and that is all. Let's quickly move to the next problem here. And the next problem, let's solve an interesting chain rule. This problem is, so I have given the following. Determine the partial derivative of w and partial derivative. So what do I have? I have w equal to square root of plus y squared plus 6 is y. Then I have x to be equal to sine of this, have y to be equal to e plus 3 minus 4s. Then I have e to be equal to over s squared, have p equal to 1 minus. Interesting. So you can see the number of functions we have here. Have w, W contains X and Y. X also has another thing. Y has some, and P has some. And the question is find the W over the T. Check oh. We want to differentiate this expression with respect to T. Meanwhile, there is no T. So what chain rule does it? You enter W, see X, Y, Z. Enter X. When I enter X, what do you see? P. Enter P. What do I see? I see T. Then that is 4. Please use tree diagram for this advice to complete the tree diagram. So to use a tree diagram, what do you need? W. That is our node, the bigger node or our central node. W contains what? X, Y, and Z, right? X, Y, and Z. Then the next node is going to be from X. What does X contain? X contain only what? P. Then Y contains what? Y contains three things. Y contains P, it contains T, and Y contains S. And what does Z contain? Z contains T and S. So that one will be T. Then it will be S here. Then let's go to the third branch. Now P. P contains T. This T here, it's done. We don't have T containing. This P also contains what? T, right? Then S. What does S contain? S doesn't contain anything. So that one too. Then when we come here, T and S, we are done. Now look at what they are asking us to find. They say find W over the T. So meaning you want to move from W to T. That is the part moving from W to T. All the different branches leading to T. You add all of them and that will be equal to D. W over the T. Then all the different branches leading to S as what? The endpoint will be for the answer for what? For the other one. So let's write down our equation. So the W over the T is equal to, now to move from the W to X is the W over the X, okay? From X to P is the X over the P. From P to T is the P over the T. W to Y, the W over the Y. From Y to T, the Y over the T. From Y to P, the Y over, from Y to S, Y over S. Then from P to T again, the P over the T. D to T is what? The Z over the T. And this is D over S. So let's do it. Now the first thing is to move to the T. So this T, where do I come from? I start from W. From W to here, we have for the W over the X. So this is equal to the W over the X times the X over the P times the P over the T. This is just one way, right? In one bracket. Plus, you're not done. I can move from W to T here too. So the W dy, the W, so I have the W dy, right? Times the Y over T. That is this side, okay? The Y over the T. Then plus, you're not done. We can also move to T this side too. Check. So the W over the Y times here too the Y dp, the Y dp times the P the T. We are not done. Plus, check, we can get T here. There is another T2 here. So we move from W to that T. So here we get the W, the Z, right? Then we get to Z to T, the Z, the T. So I have plus the W, the Z times T. And that is all. So check, this plus this plus this plus this will give us the W dt. That's crazy. Then let's do that for the WDS. So the WDS, what are you getting? You are simply looking at one, this one X and this under what's X. So you move from W and pass here. So here we get this, and not this. So to move to this s, we have the w dy. So the w ds is simply equal to the w dy, then dy the what? Yes, as simple as times dy yes, plus this one there are two. Plus I can also come here. There's another s here, right? The w dz, the w times dds. That's so that gives my like this. Good. So this is what you have here, which you clearly see here nicely, right? So I think for this problem, the goal was not necessarily for us to go through the hell of stuff and everything, and no branches. So I just showed you how you can break this down to a chewable. Chewable means that into a form which you cannot take on from there. Then you yourself just take your time and stuff, and you get the respective answers. So something like this, the w dx, you come straight. What's the derivative of this with respect to x? X is within this. So you are simply going to get, let me try and do that for you. So here we get, when you are simplifying this with respect to x, you get that 2x. 2x will come out. The whole thing times, so 2x times, when you differentiate the whole thing, I'll have 1 out of 2. This whole thing is upon negative 2. So 2x times 1 out of 2, x squared plus y squared to the power negative half, right? Then this will cancel. So the answer is what? X root. You get x squared plus y squared. That is for the x like this. Then you do for y this any term here. Then you go and do for what? You h and what do you say it? But the y dp. So where is yp? I'm lost. The x dp, sorry. The x dp. So this x. What's the x dp? The x dp is simply what? Cosine p. That's all. Come and put it there. Go and find the p d. Where is the pdt? That is it. It's negative 2. Then that is all. You add it to this, and you are good to as simple. Okay, let's try something new. And for this problem, let's solve directional. Find directional function f of x, y, x of the direction that is equal to 4. Okay, how do we solve this directional derivative problem? So to solve this directional derivative, simply have to ask yourself what's directional derivative. So directional derivative concept, identifying shortest or the longest, right? So I want to know the direction. Direction here in directional derivative formula, we have du, right, is equal to the gradient function vector. or it may be. So you find your gradient function, multiply that by your unit. So what this happening is gradient function shows how your x, your y, your z, multiply that by a certain known function, known vector given a direction, so that your derivative will then in turn change with respect to that particular direction. I don't know if you get it. So we want to find the direction. That is, we have a moving like a curve. At every point, the values of the derivative, right? So yeah, we are looking for the have this. There's a mountain here. You are standing somewhere, right? Want to connect a rope to something. There are so many possibilities how you can get this stop here. But the question is, what's either the shortest? You can do that by maybe trying to model a function or a curve from where you are to this. So we would hit this point here, the direction of that particular point. Then we would apply by that point, put the path as exactly that position. So direction derivative, just don't do partial derivative, but we need. What's the partial derivatives of a function? The function f of x y equal to cosine x. Therefore, fx equal to some sort. Change. Want to find the respect to x, that x is going to give us what y. A one of a one over then one over x over. Then this for fx, fy is difference x over negative will be divided by 1. Therefore, my gradient function comes vector with negative 1 over x over comma x over y squared sine. Then close it. What is my unit vector? My vector is given as 4. Therefore, length is plus 4. Have 1 over direction. So once I have this, and then what do I do? I simply find the dot product in my dot product means that fx times the x fy times 1 over x over right plus over 5 x over. So once you have this direction, so this directional, that is the end of directional derivative. So let me get solve again. So let's solve function r of x y x squared equal to x squared over y squared y. Find the partial derivative. This one, I think it should be very simple. I think you can do it. So the function is x squared y squared r x, or the function is here 1 over y squared plus 1. So 1 over y squared, I have x squared. When I differentiate x squared, what do I get? Answer is y squared only for this. When I come to this thing, where is x? This is where x is. Therefore, I'll have minus y squared as a plus 1. When I differentiate this with respect to x, what do I get? Convert this one in a form negative. This becomes what? 2x multiplying negative x squared plus y, the power negative. So this, right? Therefore, my answer becomes plus x, and my y squared is here all over x squared. This is for rx. Now what is ry? Ry is simply equal to, see where y is similarly. So I'm going to have 2x squared y, and that will be negative over y squared. Here y becomes minus y squared plus. Sorry, so here is tricky. Good. So we realize that for this section, we are having y squared over x squared plus. So we cannot say that this one is going to be normal one. This you have y here, you have y. So the y squared becomes my d, right? So let me make it my, let me make the y squared mine. I'm using the quotient. Let's to be equal to y squared, and therefore u prime is equal to 2, v prime is what? I'm 0. Therefore I have v over v. Thus v is x squared plus 1 times d. What is d? Prime is 2 minus my u, y squared, times v prime, which is all over squared plus y. Like this. That will give you squared plus 2 x squared plus y squared all over. So that is how we simplify. I brought this question once, so anyone can problem. So let me get you one session. Let's do some beautiful here. Okay, evaluate. So evaluate the double integral for a region 10 x squared y squared, sorry, 10 x squared y cubed minus 6a. where D is the region bounded by x is equal to negative y squared, then x is equal to y. Evaluate 10x squared y cubed 68 over region D. Region D is defined as x is equal to negative y squared and x equals y cubed. Boundaries are defined here. How do you solve this? This is double integrals over a general region. Solving the general region quickly requires you to draw. If you don't draw, it becomes because you wouldn't upper and the lower. So before you draw, you need limits. Now x is this, x is that. Negative 2y squared is equal to y. So I have y cubed plus 2y squared. Taking my y squared out and have y plus equal to 0. Right. So what will my y? Y is going to be 0. Y equals negative. Once you know y is 0, 0. Y is negative 2. Let's say negative. So this is the values for our y. We have plotted. And what is x? Let's plot x. X is what? So let's find the corresponding values of x to get a boundary. So if y is 0, x is going to be 0. You have 1 point. Y is negative 2, 8. So x is going to be what? Negative 8. Let's say this. Have it. So this is the boundaries. Then the next thing to do is for you to draw. X is a graph here. X is a graph here. So you have to draw these two. How do you draw a graph? Sketching a graph for double integrals, please just know. How do you know the double derivative? When I differentiate this twice, I'm going to 4y. I differentiate this twice. Positive is so therefore my maximum is going to be nicely. That is all. Y is equal to x is negative 2. And what will my minimum take? Take the opposite, right? So there are two ways of doing this. Now, what I'm doing is I'm plotting with respect to x. Now let's go back to the function. Here we are. I'm only going to how to find the showing you how to find the limit. There are two ways. So you would write. Let me draw mine. So when you are drawing the graph, like have mine, have mine, and I got this as a point. Another. So for x is equal to negative y squared. Okay, it's the same as so you write it and get four separate two separate that will give us whether the x or the y first. So if you have x is equal to negative 2y squared, therefore y will be equal to square root of what? Negative half x. And if you have x is equal to y cubed, have y to be cube root of, right? So you have two scenarios. And how do you please one thing you should take note of, never identify whether a function is maximum or when it is not. When y is not the subject, very important. Here I was making subject for finding them is rather to show which one will be the so when I differentiate y, you obviously that's negative, right? And that is my I differentiate y to for multiply. Okay, let me do it. So for this one, what do you get? I'll have negative half x to the power half. The first derivative will be half this minus half. Second derivative will be half multiplied. Here too, same. X to the power 1 out of 3. The first one will be 1 out of 3. X to the power 1 out of 3 minus. Second one will be and this will all be what? Maximum. So our graph is going to have a maximum curve. Just look. Here we have only two boundaries. So I'll simply also the same. So this x equals negative y squared. This is a region. So once you're able to graph this, then it means there are two ways. Either you are going to slice through the x axis, slice through the y axis direction. You slice through the x axis direction, slice through the y direction. So here, as I said, y is equal to half x. Here to this, y is equal. So whatever direction. So let's slice through respect to what? X. Slicing through x, check what you do. Cut your curve across x, parallel to x. So which one did you meet first? You met the point, and so I'm slicing through x, so I'm going to have my x to be greater than or equal to the first point. That is what first point negative. But you see, mostly when you have negative, a negative answer, which one will be positive. So I'm slicing through x, so I'm having x to be equal to this one is a small, right? This is the smallest. So the where it touches the boundaries, what you take note of. So when I'm slicing through x, it means I'm going or slicing through the x direction. Let me so meaning the first point is what x is equal to negative y squared. So you have your negative y squared less than or equal to the next one is what y cubed. That is x equals y cubed. So those are the two. So this one is bigger than this. That's why you met. Now you have this. Then your y values, once you slice through parallel to x, your y values become vertical, perpendicular. That will be from 0 to negative to less than or equal to 0. Now let's slice through y. Slicing through y, we are going to get what? I'll slice through this function so that I'll touch the boundaries in 2 points. One point here, another point, right? So what happens here is I'll have this point in my minimum. But here, since I'm slicing through y, my y will take the functional value. What the first functional value? Square root of negative half x. You get it? Less than or equal to the second one is what? Cube root of x. Good. Then my x value becomes the perpendicular. This axis I cut. That'll be 0 to what? X will be rather be equal greater than negative. These are the two boundaries. So using the first one, what do we get? Get integral from from um negative 2y squared to y cubed and x squared and all that. Then you write your dx. Using the second set, have integral from negative a to 0, then from negative x of x, then that will be dy. Any of them, you get the same. And I'll bring this session to an end for this tutorial. Thank you so much if you joined for the beginning, and please do well to watch the entire video to capture the different topics we've covered. You know the problems are plain, right? You can't go through everything. So this is God Academy once again. And if you haven't subscribed as a student, go subscribe and also hope you get updates notified by your friend. That's subscribe. And until then, that's a bye.